Okay, now we can start. Now, so this is what I was saying. So I was asking the different problems, so that from there I will be working on. So the first student proposed logic gate, the second student talk about algorithm. Good. So as usual, I'm going to give you the key points that you're supposed to master. From there you can answer any question without any stress. Now the first thing is, when we talk about logic gate, you need to know the definition of a logic gate. So what's a logic gate? A logic gate, in fact, is just a component, or you can precise electronic component, an electronic component that takes one or more input and produce a single output. The mic of someone is stepping off there. I don't know which person.
I'm not getting.
I'm not getting your point. Off your mic. What are you not getting? When I'm talking like this, you're not getting my voice. Eh? Are you not getting what I'm saying when I'm talking like this? Who is the person? Oh, are you getting me? The person is no more talking. Okay, let me just continue. Okay, so I was saying this because I'm defining logic gate because there are questions where they will ask you to define logic gate. So a logic gate is an electronic component. Someone is disturbing us with the mic there. Let me just off the person. Who is this? When I'm talking, the person is not listening. Esther. Are you people getting what I'm saying? Hello?
Yes.
Because I'm seeing the comment section too. Clarice is saying that she's not seeing my screen. Sasha is saying that she's not getting what I'm saying. So I was like wondering that maybe I have a problem on my side. Okay, if you are getting, then fine. It's okay. Maybe they have problem with their own phone or software. So if someone is not getting what I'm saying, please just try to increase the sound also of your phone so that you get well. But I think I'm audible like this. Okay. So let us try to move very far. So as I was saying, logic gate. So a logic gate is an electronic component that takes one or more input and produce one output based on a logical operation. So this is what we call a logic gate, just an electronic component that takes one or more inputs and produce one output based on a logical operation. So after knowing this definition, the next thing is you need to know the different type of logic gates that exist. So now type of logic gates here, you don't really need to cram everything, how it works and so on and so forth. You need to know that there are some gates that you need to master, which is very, very important. So if I take type of logic gate, types of gates, it is subdivided into three types, three of them. So make sure you retain it like that. The first one is what we call the principal, or we call them main gate. And here we have three of them. This is what we call the NOT gate, this is what we call the OR gate, and this is what we call the AND gate. So these are the principal gates here. Then the next one is what we call universal gate. Under universal gate, now we have just two types. This is what we call the NOR gate, and this is what we call the NAND gate. Now the last category is what we call special gate, and under special gate we have the XOR gate and the XNOR gate. It's all concerning advanced level. This is all what you need to know. Now if I take the case of the NOT OR and AND gate, let us start with principal gate. So let me just increase this first. Let me increase this, because after knowing this, it's finished. The rest we are just answering questions without any problem. if I take the case of the NOT gate, what you need to retain is that the NOT gate is the only gate that takes one input and produce one output. So if the input here is called A, the output here is called A bar. Another name of this NOT gate is what we call the inverter. The inverter. Paper 1 question, you always see this type of thing. Good. Now, the aim of the truth table now is just to show the different possible inputs and their output. Like here we are working with binary numbers, meaning 0 or 1. This all. So if a gate takes one input, it simply means that this one input can either be a 0 or 1. That is why when we draw the truth table of NOT gate, we have just two possibilities, either 0 or either 1. And the output is just the reverse. So if you have A is 0, you have 1. If A is 1, you have a 0. So this is concerning the NOT gate. If I take now the case of, let me just take the AND gate first before going to the OR gate. Now the AND gate, generally some students are confusing, I don't know why. Now here when you just see AND, it's ending with what? J. So this capital J is representing the symbol of the AND gate like this. So taking two inputs. So generally it can take more than two inputs, but advanced level ICT student, people are working just with this type of gate, taking just maximum of 2. Good. So you rarely see something. You rarely see a gate taking 3 inputs. Advanced level ICT, no, you never see that one. So now here, if my two inputs here are A and B, the output should be A dot B. Now if you go to the OR gate, so now the OR gate is similar to the AND gate, just that this back part is curved like this. So you take note of that. That's why I was saying that sometimes students are confused between this OR and AND gate. So the best way to retain is just to think about this G here at the level of the AND gate, so that you always remember that this is how we draw the AND gate. Good. So if this is called AB, the output of the AND gate here is A plus B. And this all, make sure you master all these things. Now the truth tables here, this is how we do truth table. Now truth table depends on the input. If I take the case maybe of the AND gate, the AND gate here has 2 inputs. So it means that for you to know the total combination of input that you can have inside your truth table, the formula is given by 2 to the power n. Meaning what? Since I'm having 2 input here, so n here represents the number of input. Let me just write it, number of input, like this. So for 2 input, you have 2 to the power 2, which is equals to 4. So meaning that your truth table must have 4 different combinations. Now, generally, it's when you are working with logic diagram or circuit diagram that you can have more than 2 inputs. In that case, your truth table will be different. So the case of 2 input, this is how the truth table look like. So you have A, B. Since here you have 4, just come and take 4 divided by 2. 4 divided by 2 is what? It's 2. So this 2 here simply means that, let me just clean something, please. Good. So this 2 here simply means you write 0. What's happening here? This 2 here simply means that you align 0 here, you write 1, 1. You come to B now. B here simply means you take again this same 2 up there divided by 2, which is giving you 1. So you say here 0, 1, 0, 1. And not the reverse. Some students are drawing their truth table, they write but 1, 1, 0, 0, 1, 0. No. When you are doing that, you are just writing the reverse numbers. And generally in the exam, you are supposed to follow by this order here. Now, and it's all, you just need to know the principle of it. If I take the case of the AND gate, which is A dot B, AND gate is just like multiplication. So like 0 times 0, 0, 0 times 1, 0, 0, 1 times 0, 0, 1 times 1, 1. So in the exam, if they ask for the principle, in fact, of the AND gate, you just say that the output of an AND gate is true when both inputs are true. So 1 here means true, 0 means false. Or another person can say the output is 1 when both inputs are ones. Good. Else it is 0. So this is how you retain it. Now imagine that you want to draw bet for the OR gate. So the OR gate is A plus B, like normal addition. So A plus B here is saying that it's only when both inputs are 0, 0 that you can have 0. Else you have bet a 1. Like A and here you have 0, 0, 0. So the rest now, here 0, 1, 1, 1, 0, 1, 1, 1 is 1, 1 is 1. And now, by the time you know this, when you're working now with the NOR gate or NAND gate, no need to retain something there. No need to retain, it means what? Like here, if I take the case of the NAND gate here simply means NOT plus AND. So it means that if you know how to draw the AND, indicating the NOT here becomes easy. You just need to ask yourself how to indicate NOT at the level of this AND gate. It's clear, NOT here represents NOT gate. Just that you not come and redraw this NOT gate here, no. Generally, we just add a circle here. When you see a circle here, it means that this gate becomes a NAND. So this is how we change at the level of the symbol. And at the level of the Boolean expression, what happened? Boolean expression, we just put a bar, here. Meaning what? In reality, this is what happened. In reality, normally this is how the thing is looking like. I'm having something like this. Yeah, I'm having my NOT gate like this. Good. Meaning that the output of this AND gate is what? Is A dot B. And that A dot B is entering into the NOT gate. And when you enter here, we know very well that when the NOT gate takes something, he is supposed to bar what he's taking. So this is the real diagram here. Just that to shortcut it, than to redraw back this symbol, we just put a circle here. So understanding this principle is easy. Now the NOR gate here means NOT plus OR. So you know the OR. Just ask yourself how to indicate NOT. NOT means that okay, you come here at the end, you put a circle and you bar everything. So this is how you retain. Just to tell you that when you are reading, don't cram. But when you draw something, ask questions to yourself so that at least when you are doing something, you are sure of what you are doing. And since you know the meaning of bar, imagine that they ask for the truth table now of this thing. It becomes very easy. Generally, always detail what you are doing. Meaning what? If they ask the truth table for the NAND gate, so start by drawing the truth table for the AND, meaning start by drawing A dot B. So that now for you to have the NAND gate, you just come and add what? You just come here and you say A dot B bar. Meaning that result you have for the normal A dot B, you just bar it by doing what? Taking the reverse. So meaning where you have 0, you take 1. Where you have 0, you take 1. Where you have 0, you take 1. Where you have 1, you take 0. So this is how we reason. In fact, the same thing for the XOR, for the NOR gate first. Just draw your normal OR first, then you just come and bar each of the output to obtain your result. So it's all for that one. Now let me just mention the last gate, then we go and take past this equation. You see how it works. Let me take the last case. Let me just increase this first. Okay, the last case here is the XOR gate. So now you realize the XOR gate is completely different from NOR and from NAND. There is no N here. So it simply means that you will never, because what happens here is you see XOR. XOR here simply means what? Exclusive OR gate. That is the full meaning here. So when you are drawing something like that, to be sure that you always remember, start by drawing the OR first. You draw your normal OR. This is how the OR look like. Everybody know how the OR gate look. If you know very well how the AND gate look, you must know how the OR, because I've explained how to recognize the AND gate just by thinking about that last letter G. Now, so this is my normal OR here. Good. But now the question say XOR, and you know very well that you cannot come and add a NOT here, nor a bar here, because adding a 0 here and a bar here, it means that you are already made NOR gate, because NOR, the NOT of the NOR gate means whether you note this symbol and you bar the Boolean expression. So you just ask yourself that okay, how to include the X. So there's no other option than doing what? So generally we just double this back part like that. So this is how we indicate that on the symbol. You double the back part. This curved part here, you double it. Now at the level of the Boolean expression, what happened? You circle the plus. So this is how you reason to always remember, so that you don't go and confuse. Maybe you see NOR gate, you say it's XOR and so on and so forth. And why am I explaining this? Because by the time you know this exactly the way I'm explaining, I'm not saying which circuit diagram can be more than you. It's not possible, because circuit diagram here simply means what? Combination of logic gates, in fact, to produce an output. Meaning what? We are no more using a single gate to produce an output. We combine multiple gates, and when you master each of these gates, finding the output of a logic diagram becomes very easy. Now, what's the truth table of this XOR gate? So the principle here is clear. The principle here is very, very clear. 0, 0, 1, 1, 0, 1, 0, 1. So the principle here is saying this, that identical input give a 0 output. So that is the principle of the XOR gate. Meaning what? If I draw X or B here, identical input 0, 0, you put 0. 0, 1 is not identical, so you put 1. 1, 0 not identical, you put 1. 1, 1 they are identical, so you put 0. So the principle is clear, as I was saying. Identical inputs give a 0 output. So this is how it works. Good. So you are seeing that if tomorrow now in the exam they say XNOR gate, you don't stress yourself. In XNOR gate you are having N, and you know that N means what? Not. So it simply means that if you know XOR, for you to indicate the NOT, what happened? You come and circle this thing. Let me just use another pen. You come and circle this, and you put what here? You put a bar. This is how you reason. Now, the next thing I want to mention is this XNOR gate. Sometimes it is represented using this symbol. Like than to circle the plus and putting the value, just put but A, they put a dot, the circle, then they write B. So in some textbook, those reading textbook, I don't know, surely you have seen this before. So it's all. Now let us go to questions. Let us go to questions so you can see how we answer past question. Let me just take some questions. Even GC equation, we can answer GC equation. ICT A-level 2025. I think 2025 is how this equation there. Okay, 2025. Is there any question on a logic gate? I think no. Okay, we will go to 2024. Yeah, so you have seen that if there's no question on a logic gate on this year, expect that in 2026. That's clear. Okay. Now before even going to questions, so let me just ask, is it okay for everybody? So all this explanation, any question? Is it okay?
Yes, sir.
Only one person is answering. I'm not getting. Yes, what are you saying?
I cannot see the computer.
You cannot see the computer. How? This is it now. I was explaining here. Are you seeing this page?
No, sir. I'm seeing your.
You are seeing my.
Your photo now, sir, but not.
You are not seeing my screen. I'm sharing my screen. Are you not seeing the screen?
You should go out and enter back.
Try to go back. Try to go out and enter back. And I've realized that maybe some phone are not really supporting this screen sharing. So that's why maybe you're not seeing it. So I don't know why. Because if you're not seeing it, means you just look at the replay after when we post it on YouTube. Are you getting it? Okay. So if
Yes, sir. Can we have a word?
Yes. I'm getting you.
Please, can we do for 3 inputs or 4? Because I'm having a problem drawing the truth table.
Yeah, we are solving question. I'm done with the explanation. I'm going through question. Let us just go through question. So surely I will take a question like that. Or let me just propose a question first before we even move. Okay. Let me just.
There is a good question in June 2018.
2018. Okay, yes, I will go to that year. Wait first. Let me just do something, please. I will go to 2018. Let me just take some cases first. Now, so let us take question 1 here. Question 1. A minute. Okay. Question 1 here. So draw the secret I'm not sure. Is it visible? What I'm writing, is it visible? Hello?
Yes, sir.
Because when I increase...
Yes, sir. It's visible.
Let me try to... Okay, let me write it back. So this equation here, equation 1, they say... Question 1, they say draw the circuit diagram of the expression let us take something like a dot b bar all that dot c dot C bar. Okay, this is an expression here, and draw it truth table. Okay, so this equation here. Now, to do so, let us move gradually. When you're having something like this, and they ask you to draw the circuit diagram, because this question, I think June 24, we have something similar, but we are coming there. Now, so solution here is very clear. So always try to identify your different inputs. So the input here simply represent the different letters you are having in your Boolean expression, because this expression that you are having is what we call a Boolean expression. And in this expression, I'm seeing that I'm having what? A, I'm having B. Let me just write the B well. I'm having A, I'm having B, and I'm having C. So it means that here I must have 3 inputs. So you just come and you draw A, you write A, sorry, you write B, then you write C. You draw 3 lines like this one. 1, 2, and 3. So this is step number 1. Now, the first thing that you realize here is, here you are having what? B bar. And B bar simply means what? That you are having the NOT gate, and that NOT gate, what happened? B enter in that NOT gate, and what come out here is what? Is B bar. So you go gradually. So this is the first thing to do. Now, after doing B bar, you realize that you have A dot B bar. And dot here means what? AND gate. Meaning that you are supposed to draw your AND gate where the first input is what? A, the second input is what? Is B bar. So you come and draw something like this. This is my AND gate here, AND gate capital G. The second input is B bar. So let me just try to arrange something. Let me just put this one a little bit down. Good. So that's why sometimes you may use your pencil in the exam, so that any mistake you can correct. Good. So because I'm seeing here B bar is the second input and A is what? The first input. So yeah, what happened is, let me even clean this one. Okay. So what happened is, you draw your AND gate here, and your first input is A. So you take this line, you go and join it to A. The second input is what? Is B bar. So make sure you draw your NOT gate here. Go to join it to B, because B must pass through this NOT gate to produce what? B bar. And always hide that output after that gate, so that you always remember and know exactly what you are doing. So now for the AND gate, make sure you hide the output of the AND gate. So AND gate is what? First input, which is A dot, second input is what? B bar. So you're seeing that everything is corresponding to what you are trying to do. Now continuation, you are having dot C bar, but this dot here is an AND gate, and this AND gate takes what? So always analyze, when you see a gate, the input of a particular gate is always what is found on the left and the right part. So this dot here means AND gate, and what I'm having on the left is all this part. On the right, I'm having what? C bar, but I'm not yet having C bar here in my secret. That's why I'm not drawing the AND gate representing this dot. So you do it after. Now, so let me continue. So meaning what? The first gate that you're supposed to draw here is what? Is the NOT gate to represent what? C bar. So you come and draw your NOT gate somewhere down here, like this. You draw the line to C, knowing that, okay, after this gate, what come out here is what? Is C bar. From here now, you can draw your AND gate in such a way that you take this arrow, you bring it down here for the first input of this one, and the second input is what? Is this C bar. You bring it here, so that hide your output to be sure of what you are doing. First input of this gate is what? Is A dot B bar. Okay, now dot, the second input is what? C bar. You hide your C bar. So at the end is how you obtain your circuit diagram. So you move step by step. So I don't know if there's another question, or let me just take another example before we go to truth table. Is it okay?
Yes, sir, it's okay.
Nice. So let me take the case of June 2024. I think, yes, 2024. You're having something like this. Let me just write that expression here, so that after that we can just draw truth tables now. So that let me explain how to do so. So 2024, now this is what happens. You have something like this. A dot b all that bar plus a dot b bar. Okay, these are the expressions that you are having here, and it asks you to draw the circuit diagram. Circuit diagram. So how to do so? Solution, the same procedure. You start, you analyze it that you have a dot b all that bar, but you know very someone the mic off your mic. Okay, you realize that you have a dot b. So and there's something you need to know. Please always start from left to right. Good. So yeah, I'm having a dot b, and we know very well that dot here means AND gate. So draw your AND gate first before even thinking about any other thing. Or before that, wait, I'm missing something. Okay, so before even drawing the gate, see, because we have different methods of doing so, so I'm just trying to bring out a simple method that you can really easily return and you use it each time you want to work. Now here you analyze this Boolean expression first, step 1. Under this Boolean expression, what are the total number of inputs found here? I'm just seeing two letters, A and B. It means that here I'm going to have input A, input B. You draw your lines, okay. Now you start. Your first Boolean expression here, the first expression here is A dot B all that bar. But you know very well that A dot B alone is the AND gate, meaning that you have something like this, A dot B. So you have something like A dot B. But now you are seeing that everything is bar. So if everything is bar, it simply means that this thing is passing through a NOT gate. So this becomes what, the NAND gate, so that you can have what, this bar here. So this is how you're raising, so that you always remember what you are doing. Now the next thing here is what, is plus. You are seeing that this plus here means OR gate. OR gate between what and what? Between A dot B all that bar and what? A dot B bar. But A dot B bar is not yet there. So you start by doing A dot B bar before you come back and draw this OR to join the two. A dot B bar. So dot is coming back. So if dot is coming back, it means that here should be the AND gate, because the AND gate is dot. Now the first input of this AND gate is what? Is A. You join this line just to A like that. The second is what? B bar. So you draw your NOT gate here first before joining it to B, so that when B pass here, it come out here, it becomes B bar. You write the expression first. The expression is what? A dot B bar. Now, so all this now input, all this, what you are seeing down here is the second input of what? Of this OR gate in the middle here. So you come and draw your OR gate here. So that OR gate, you know very well, you curve this, you draw something like this, you bring this line here, first input, you bring this line here, second input. So at the end, always write the expression to be so. So first input of my OR gate is what? A dot B all that bar. Okay. Plus second input is what? A dot B bar, like this, and this is your final answer. So please, when you're drawing this, go step by step gradually, and you always have the correct result. So this one is sure 100%. So any question for this second part? Is it okay? Is it okay for everybody?
Yes, but in the question they gave also A plus B all that bar plus A bar dot B bar.
Which question?
That's 2024.
Yes, but from what I've solved here now, you cannot solve the other one. The same principle.
Okay, sir.
Yes, meaning that when I'm doing something like that, your work now is what? Go and try the other one, following the instruction I was giving here. Then that's like really proving that you're understanding. I don't know if you're getting the point. So that if you feel that you have a problem, you bring it back. Or if you do, you're not sure, you send, let me verify if what you did is correct. Are you getting it?
Yes, sir.
Good. So it's exactly what we are trying to do. That's why I'm just taking some random example, so that I'm explaining by the principle. Then you go and solve other question. Now, let us come back to this first question. They ask us to draw what? The truth table. So what is the expression? Let me write by the expression down here. Okay, the expression here. So they are asking us to draw the truth table of the expression A dot B all that bar dot what? Dot C bar. Okay. Good. So how to draw this truth table? Oh, sorry. So how to draw this truth table? Now, the first thing before drawing the truth table, or let me just start drawing this. The first thing before doing anything here is to determine the number of input. I will always repeat this. Now, you analyze from this expression. Let us say I'm calling this expression maybe Z. Just call it how you want. I'm seeing that I'm having A, B, and C. So I have 3 inputs here. Now, if I have 3 inputs, what the total number of combination? I said that the formula was 2 to the power n. And n here is what? Is 3 for number of inputs. So the total number of combination in this case is 2 to the power 3, which is 8. So meaning that you are not supposed to have truth table looking like this, just with 4 combination. No. By the time you have 3 inputs, you have this type of truth table. The examiner just cross it directly without thinking, because you are wrong at the beginning. Without even looking what you did is wrong. So knowing the total number of combination is important. So now here having 8 combination means what? How should draw the truth table? Let me just start indicating the input first. A, B, and the third one is C. So it's the same principle. Just take that total number of combination, which is 8, you divide by 2, 4. Why are we dividing by 2? Simply because we are working with binary number. Binary here means base 2. So that's why I'm doing my division by 2. So 8 divided by 2, I'm having what? 4. So you take 4 zeros, 1, 2, 3, 4, and 4 ones, 1, 2, 3, and 4. You take this same 4, you divide again by 2, you obtain what? 2. So you repeat the same procedure that you're aligning number 2 zeros, 2, 1, and so on and so forth. So 0, 0, 1, 1, 0, 0, 0, 0, 1, 1. You take this same 2 again, you divide by 2, you obtain what? 1. So meaning what? You take 0, 1, 0, 1, 0, 1, 0, 1. So this is your truth table, and this is what you are using. Now, solving this, now what happened? Let me just take another color. The first group here, you realize that you are doing A dot B bar. But you try to think, A dot B bar, dot there is the AND gate. Okay, no problem. But B bar, is B bar an input of your table? No, B bar is not an input. And the input you have here is but B. So it means that you have to create B bar. So you come and add a new column here called B bar, and you fill it. And B bar means what? Remember, that's what I was saying, that knowing the principal gate are very important, because everything is turning around that. Bar here means not, and we know very well that not here simply means we invert, in fact. So if B here is having 0, 0, you put 1, 1. Then 1, 1, you put 0, 0. 0, 0, you put, hope I'm following these same lines. Wait, let me clean something. Follow the line. 0, 0. Here is what? 1, 1. Yes, what? 0, 0, 0. Good. So I'm done with B bar. Now the question you ask yourself, can you solve now A dot B bar? Yes, because A is existing on your table and B bar is existing. So you can now include a column A dot B bar. Now when you include a column A dot B bar, there's nothing special. What happened here is you are doing your normal dot, meaning your normal AND gate. But just that you are using the column A and B. So and A and B bar, sorry. So it's similar to what we did here. A dot B. So we are using the same principle. A dot B is the AND gate, and the AND gate says what? That it's when both are 1 that you have 1. Or if you want to do but multiplication as I shown you before. Good. Just that this time around, the formula is saying what? That A dot B bar. So you are doing that between the column A and the column B bar. So you analyze A and B bar. So here I'm having 0, 1. So automatically is 0, because 0 times 1 is 0. So here 0, 0, 0. Now you analyze here, you have 0, 1, you have 1, 1, so here is 1. Now here you have what? 1, 1 also, here is 1. Here you have 1, 0, 0, 1, 0 is what? Is 0. So this is my A dot B or dot B bar. So now A dot B bar is already existing in your tables. Normally you are supposed to take this A dot B bar and do the AND gate with what? C bar. But you ask yourself, is C bar existing on your table? No. So you create the column for C bar first before doing something. And C bar here, where the column C? This is it here. So you just invert each value there. So it's what? The first is 1. So the first is what? 0. So you put 1, 0, 1, 0, 1, 0, 1, 0. So C bar is existing. So it means now you can do your normal A dot B all that bar dot C bar. And I've called that what? I've called it Z. So I can just write Z here. Go. If you don't want to write Z, you rewrite back all this. There's no problem. So now, and what are we doing here? Z here is what? Z is this column. Let me take another pen. Z is this column and this column. So meaning you are doing your normal AND gate, just that you are now using by this column. And what is AND gate saying? Like multiplication. So here is what? 0, 0, 0, 0. Here is what? 1, 0, 0, and 0, and it's all. You are done. So when we are marking this scene, and this is how we are marking it. The first thing, when there's an expression like this, when I'm in front of a paper, by the time I'm seeing you are having 3 input as required by this, you are already having a mark with just for that. Before even looking at final output, you're having a mark for that. But when you're having such expression and your truth table is just 4 combination, 0, even the output you are not even marking again, you have 0 completely everywhere. So just to tell you that, please always focus when you're doing your thing, because when you don't focus, sometimes people fail just because you are neglecting things, you're just there doing things without even thinking. That's why you fail. Whereas someone can just follow instruction, the person is not even intelligent, but at least he's having marks for some certain things. So now, if this question is maybe 4 marks, you have maybe 2 marks, 1 mark for this first part here, like indicating your 3 inputs, and the rest of the marks is shared now for this output here. The final output maybe can be 1 or 2 marks, sometimes it depends. So this is how you do so. Any question for this truth table? Hello? Nobody's answering. Are you people following? Hello?
No question.
No
Yes, sir.
question, sir.
Okay.
No question, sir.
Fine. Fine. Okay. So we go and draw the truth table of this last one, and I think it's all A. So after doing this, another thing I will mention on the logic gate, but after that it's all. Now, this second question, the Boolean expression is what? The Boolean expression is A dot B all that bar plus A dot B bar. Okay. So they are asking you to draw the Boolean to draw the truth table. So here you identify the number of inputs. You just have A and B. So A and B means 2 inputs. So the total combination should be what? To the power 3, which is what? 4. It means that for this second one, this is how your truth table will look like. You have here A, you have here B. And 4 here means what? You take 4 divided by 2, which is 0, 0, 1, 1. And 2 divided by 2, which is 1. So 0, 1, 0, 1. And you can really count there. If you come 1, 2, 3, 4, it makes 4. Even this other one, if you count, you have 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is another way to be sure of what you are doing. I'm saying that because I've marked some paper where student maybe the person know how to calculate total number of combinations. Like the person do 2 to the power 3, it gives 8. But that person come and say 8, 0, 8, 1. At the end, it found himself with 16 combinations. It's not more making sense. So just to tell you that be curious in what you are doing, and there are certain things you will never forget also when you are working. Good. So please take that into consideration. So let me clean this. Okay. So for this expression, what happened? The first group here is what? Is A dot B all that bar. The mic, who is disturbing there? Ali Junior, your mic. Okay. The first group here is what? Let me just call this expression Z. Okay. The first group here is A dot B all that bar. So the next advice, when you have something like this in the exam, start by solving A dot B, because A and B are existing in your table. Now you create another column where you just bar the result of A dot B. So A dot B here is what? Normal AND gate. So 0, 0, 0 here is what? 0, 0 here is what? 1. So normal multiplication. Now bar here means that the result you had here, you just invert it. So 1, 1, 1, 0. Go gradually, step by step. The next here is what? Is this plus here, but you cannot solve this plus because this plus here is taking first input A dot B all that bar, but second input is taking A dot B bar, and A dot B bar is not existing. So start by solving A dot B bar. But also you cannot solve A dot B bar because B bar is not yet there. So you start by putting B bar first. B bar, where is the column B? So this is it here. So it's 1, 0, 1, 0. So now since B bar is there and A is there, it means that you can solve A dot B bar. So it means that you are doing a normal AND gate, but between the column A and the column B bar. So we analyze it together. So 0, 1, it makes 0. 0, 0, 0. 1, 1, it makes 1 here. 1, 0, it makes 0 here. Good. So you are seeing that now the column A dot B all that bar exists and the column A dot B bar exists. So you can now solve what? Z itself. So Z here is what? Z is just the OR gate of this column and this column. Good. So now let's all do it together. So 1 0 OR gate here is plus, and plus is saying that it's only when both are 0 0 that you have 0, else you have 1. So 1 0 here, it means you have 1. 1 0 you have 1. 1 1 you have 1. The last one is 0 0, so you have 0. So at the end is what you have, and it's all. So if someone has a question to propose under this, we can solve it. If there's no question, then fine. This is all about logic gate. The next you need to solve more questions. But before closing the chapter logic gate, the last thing you're supposed to know here is what we call De Morgan's theorem. De Morgan's theorem. Let me just go to De Morgan's theorem. The De Morgan's theorem and a little bit of Boolean algebra. So let me just talk about De Morgan's theorem. Good. Either you see De Morgan's theorem or sometimes you see De Morgan's law. So it's the same thing. So we have two laws here, or let me say two theorems. So the first one here is, what you need to know is that the aim of this De Morgan's theorem is just to break a bar between inputs. Meaning what? The first law is saying that when you have something like A dot B all that bar, this is equivalent to A bar plus B bar. Meaning what? That here the bar is shared between A and B. So to break it so that A is having its own bar, B is having its own bar, you must change the sign. So yes, since you are having dot, that is why the thing changed to plus. So this is exactly what happened. And second law states this, that when you're having but now A plus B all that bar, so the equivalent should be what? The same principle. You take A bar, the plus must change to what? Dot, then you take what? B bar. So this is how De Morgan's law works. And by the time you have this in mind now, you can solve question without any problem. Like there is a question I want us to answer related to this one. So but before going there, the next thing I want us to discuss is Boolean algebra. Now concerning Boolean algebra, there is really nothing difficult here. Meaning what? Let me just take an example. Here there is not something like to cram or no, nothing like that. Like if they ask you what is A dot, let me just say A dot A. So no need to cram that A dot A is A or is 1 or no. If you are doing that, you are wasting your time. By the time you have something like this, and generally this Boolean simplification is when you are having an expression with the same inputs. Like if you have something like A dot B and they ask you to simplify, this is not possible to simplify it because you're having what? Different input here. So there's nothing to do here. A dot B remain A dot B, but A dot A you can simplify this because you have the same input. Now how to do so? Generally this is what you do. You take this input called A and you let it to be 0, because remember here we are working with binary numbers 0 and 1. So to simplify this, you just need to know the output when A is 0 and the output when A is also what? A is also 1. So we test the two cases because these are the two cases A. These are the two values A can take, either 0 or 1. So we analyze. When A takes 0, what happened? Let me take a green pen. When A takes 0, it means that here you have what? 0 dot, the second A is what? 0. And 0 dot 0 is equals to what? 0 dot 0 is equals to 0. Normal AND gate multiplication. 0 times 0 is what? 0. But imagine that A is 1. What happened? When A is 1, you have what here? You have 1 dot what? 1 dot 1. And 1 dot 1 is what? Is 1. So you realize something. You realize that when A is 0, the value is 0. When A is 1, the value is what? Is 1. So you are seeing that A dot A is the same as what? Is the same as A. Meaning what? For a particular value of A, you still have that A as answer. When A is 0, I'm having 0, meaning that the answer is still A. When A is 1, I'm having 1. It means that the answer is still the same A. So A dot A becomes what? Becomes A. Another example. If I take something like A dot A bar, now the same principle. Just let, if A is 0, what happened? A is 0, you put 0 dot 0 bar, because here is A bar, so it makes what? 0 bar. So this becomes what? Let me just write this bar. This is the same as saying that 0 dot 1, and 0 dot 1 is what? because 0 bar here is 1. So 0.1 AND gate. AND gate is saying it's only when you have 1 that you have 1. So 0.1 is what? Is 0. Good. You go to the next. Take now when A is equal to 1 and see the output, because you cannot conclude with the first option. You must take the second option before you conclude. Let me take a red pen for the second option. The second option here, you have what? A is what? 1 dot A bar, so 1 bar, which is equivalent to what? Which is equivalent to 1 dot 1 bar is what? 0. And what happens here? 1.0 is equivalent to what? 0, because the AND gate is saying that it's only when both are 1 that you can have 1. So since one person is 0, it's what? Is 0. You realize something. When A is 0, your answer is 0. And when A is 1, your answer is still 0. It means that A dot A bar is what? Is 0. Because for any case you take for A, you have 0. So A dot A bar becomes 0. And here I'm just taking an example with A. Take note. So if you write a B dot B bar, it's the same thing. Good. So this work for the same input. Good. Take note of that. So this is another formula here. So sometimes in textbook you just see this formula there, but generally this is how they are being formed. So you don't need to cram. You just need to be working like that and knowing that A dot A bar is 0. No need to retain that. Let me just take the last situation here. Last situation. Let us say I take something like, let me just take what? Maybe A bar, maybe plus 1. Okay, this is something here, A bar plus 1. So here what happened? You can simplify this because you have just one input, which is A. Remember that this simplification works just with one input. So you have something like this. You start when A is, let me just take another pen. When A is what? 0, what happened? 0 bar is what? 0 bar plus 1. So this is equivalent to what? 0 bar is what? It's 1. So you're having 1 plus 1. And 1 plus 1 is what? This is OR gate here. 1 or 1 is still 1. So these are the OR gate. Don't forget, please. These are gates here, or AND gate, as you know. Good. Now, this one A is what? 0. Now you test. When A is 1, what happened? When A is 1, you come here, you have, let me take another pen. You have 1 bar. 1 bar plus 1 is equivalent to, this 1 bar makes what? 0. 0 plus 1. And from OR gate, what happened? OR gate is saying that only when both are 0 that you can have 0. So since here one person is 1, it means that the answer is also what? 1. So you have seen that for this expression, when A is 0, you have 1 as answer. When A is 1, you also have 1. So it means that A bar dot 1 should be what? A bar plus 1 should be 1. Exactly that. Because for any value of A, you have 1. So all these tend to what? To 1. So you need to have this in mind for Boolean simplification, so that when in your Boolean expression, when you be having something like that, you know how to simplify it. So before we go to exercises, any question here? Any question? Are you
No, sir.
Yeah. Are you okay on how Boolean algebra works?
Yes, sir.
Fine. So knowing this is very important. Now let us go to questions. The next scenario, there is also this thing of Boolean simplification, but there I don't want to waste time. Meaning what? Example, e.g., imagine that you have something like A dot B plus, or let me just take the case of, let me just take this first. Imagine that you have something like A plus B dot, maybe A dot B, and it asks you to simplify this. What happens here? It's easy. Now here you do your normal multiplication. You do A times A is what? AA plus what? So you start by doing, I think everybody know how to do. Everybody is doing math. So you take this times this. Then you take what? A. Yes, plus, please. I did a mistake here. Let me put plus first. I will change it to dot after. Okay. Then you take A times B. So here is plus. So you make A plus what? Plus A. Oh, why am I using a red pen here? Plus A, B. You are done with that. Now, the next thing is what? You come and take now B times A after you take what? B times B. So here you have what? After taking this, the next is what? Plus B, A, plus B, B, B. So this is what you have here after doing your multiplication. The next thing is what? Remember that where you have group of the same input, you can simplify them. So AA, you just go on your rough work, you write A dot, AA means A dot A. So you start, when A is 0, what happened? You have 0 dot 0. 0 dot 0 is what? 0. When A is 1, what happened? You have 1 dot 1, which is what? 1. So you have seen that for a value of a, we are still having that value. For when a is 0, you have 0. When a is 1, you have 1. So you have seen that a dot a remains what? Remain a. If a dot a is a, means that b dot b is what? B. So all this simplifies to what? All this simplifies to a plus ab plus b. A is the same as ab. So I can just write it like that, plus what? Plus b. Now you look for common terms here and factorize. So if you look this very well, this, you realize that a is common, or maybe b is common. So you factorize any. So this becomes a plus, let us have factorized a. I'm going to have what inside? B plus b plus what? B. So b plus b here is something you can simplify. Also, you go at the level of your whole for you write b plus b. So you test. When b is 0, what happened? You have 0 plus 0, which is equals to what? 0. And when b is 1, what happened? You have 1 plus 1, which is equals to what? 1. So you try to analyze. When b is 0, you have that 0, which is b. When b is 1, you have that same 1, which is b. So you mean that b plus b is what? B. Good. So you come back here. You write a plus a. All this bracket was what? B. So plus what? Plus b. So this is what you are having here. You analyze again. You realize that something is common. Let me just arrange this. Let me just increase this. So yeah, you realize something. So there are different things you realize here. That this first group A is common, or the second group you say that B is common. Let me just take the first group. If A is common here, what happened? I factorize A, I obtain what? 1 plus B plus what? B. Now what happens here? 1 plus B. You're having just one input here, B, and you have a 1 here. So it means that you can also simplify. You go to your half for 1 plus B. You start. When B is 0, what happened? When B is 0, you have, let me just do something. When B is 0, you have what? You have 1 plus 0. 1 plus 0 is what? Is 1. And when B is equals to 1, what happened? You have 1 plus 1, which is equals to 1. So you have seen that for any value of B, you have just 1 as answer. So you mean that 1 plus B should be 1. So you come back here, you mean that this simplifies to what? To A times 1, which is A, plus what? Plus B. And here there is no simplification to do again. So this is your final answer. Good. Have you seen how it works? Is it okay? Is it okay?
Yes, sir. Yes, sir.
Okay, fine. So you can move. Fine. Okay. Now, let me just take one past question.